This is mostly right now with OCI data that we're going to work. In the future, there will be the other instruments on the OCSSW, but it's not available yet. But OCSSW is basically the engine behind the CDAS GUI. That is the official data processing software of the ocean biology data archive. There's two A's that I'm not sure, but OBDAC. So it's the official software that processes the data. So when we talk about level 1, level 2, level 3 data, it is processed with that software. And even though the data from all those levels is available, you might want to customize your product. So we're going to show you that today. So I'm going to go over an overview of the different types of functions that are available with OCSSW, but not all of them, because it's an extremely complex and rich software that is very powerful to do all sorts of things. So there is no way we could cover everything here. It's been worked on for decades. It's a very great thing. So we're going to show you an overview, and Anna is going to dive deep into the most famous function, which is L2gen, the level 2 generator. So this is we are going to open the notebook on the website. Did you have? Okay, just to be sure. Thank you. It's the OCSSW processing tools notebook. You need at least 7 megabytes of memory to run it, and it's going to look like this. You might find it a little bit slow if you run it with me. I have pre-run mine just in case, because I didn't want to wait too long with you, but I'll try to still go slowly enough and step by step. What we're going to do today, we're going to learn how to process level 1B data that we download with level 2 gen. Level 1B data from the cloud. This is a new thing. We are developing actively this capability. Our team of programmers is working really hard on this. We have Alex Semenov, Ian is super involved in that, Anna, Don Sheus. You might run into his name if there's errors that you see today. Don't be surprised if you see errors with OCSSW. The inputs are complex, and it's a learning process for everyone. So expect to see some errors, but there's a lot of hard work being done right now to make this accessible to you, and we're really excited to show it to you through a notebook and the CryoCloud environment that Ian set up for us to use it here. This is a really unique thing, and it's a really amazing tool because you don't have to install it on your own laptop. You can just use it in CryoCloud and it will work. And this is a really big advantage that you have to be able to use it like that. This is a really great thing that Ian has set up for us. There is a notebook on the Help Hub if you want to install those tools on your own machine and not use it in the cloud. For some reason, if you don't, if you don't want that, but I really recommend using this in CryoCloud like this. So we're going to process our data, merge 2 images to do a spatial composite with L2 bin, and we're going to create a map with L3 map gen. So first, the setup, we're going to download import our libraries. It's most of the regular libraries, but we have some file management tools, CSV, OS, and PATH. Those are the regular. Yes?
Are people able to download that notebook from the website? Oh, okay.
Great job, everyone. Okay, so here we have a function that's called write par. So the input for those functions are parameter files or par files that include all the parameters that we want to run our process. So we'll see what they include in more detail, but historically it would be a text file that, that you input in OCSSW on your laptop. But here we have a function to write it directly in our notebook like this. So this is what this function does. And there is a nice little doc string that Ian made, so we have some help on the function here. Now we're going to get our level 1B data from the cloud. So with Earth Access, we're logging in, as we did previously. And now a new thing is that we need the S3 credentials to process data in the cloud. So this is what this step is. So the S3 is for Amazon Web Services. And now we're going to search for our data as we did before with our time span and our location and get our results. That's the part you have already seen. And now we're storing the results in something called an I file. So in our parameter file, we have our input file, which is I file. So the result of our search is going to be the input for our processing. And now we are going to open our I file. So yeah, you can see it happen as usual. And we can just look at our data set. OK, does it look right? we plot it really quickly. It looks all right. It's a level 1B, so we have to select the band by number and that wavelength in the red part of the sensor. But yeah, everything looks right, so we can continue with our processing. Now we're going to use L2Gen. As I said, it's the level 2 generator. This is the most used and famous function of OCSSW. And this is typically done with bash. On our, well, it works with bash, actually. And if you do it with the command line on your computer, it will be in your terminal. But here, Ian has set it up so that we can work from this notebook. So I will let him, because this is all in active development, it just added this new way of doing it 2 days ago. So I will let him explain how this part works.
So just very briefly, as Karina said, we have the OCSSW tools installed on this machine that you're working on, and they're located at OCSSW root. That's a variable that is defined on your system-wide, and we just have to access that from Python, and there's a little trick. It's this exclamation point. So we're going to get access to this OCSSW root variable. It's defined on the system, so that's why we get it from the operating system environment. So operating system environment, and we get OCSSW root. That points us to where the software is. So we just have to check that. This is just a little check to make sure that the file we need exists. When we use it, we just use this exclamation point. An exclamation point in a Python notebook says, send this command to my system. So it's not a Python command anymore. It's a system command. So it's saying, send this line to my system. And we just do 2 things. We use one shell command, one system command called source, which just says, read in this environment file that provides all these definitions. And then in that same process, and that's important for people that know about Linux processes, you understand what that means. For people that aren't concerned about Linux processes, just know that these things have to happen on the same line, separated by a semicolon. So we source that environment, and then in the same process, we run our OCSSW commands, which Karina is going to tell you all about.
Thank you. Yes, so that was very clear, much better than I could have said. Thank you. So we then need to set up our cloud processing credentials. It's a second step for that. So we are going to set it in our environment here. So it's just this command. Yeah, it just needs to be there like that, and you'll be able to access the AWS environment to process. So now what we're doing here is to look at the help for L2Gen. So that's how you get the documentation for the functions. You can either just type the name of the function, like just L2Gen could have given you also the help, but it's more intuitive when you actually ask for the help, so it both work. And then you can find what types of inputs you can have, what are the options, because you can set there's a wide array of things that you can do with L2Gen, and there's a lot of information about that. So yeah, different resolution, different type of atmospheric correction. Like I said, Anna is going to go deep into this. So today I'm just going to, well, right now I'm just going to show you the chlorophyll product. Just a quick run like this with not many special options, but you can see here when I'm just running through all the different things, yeah, that's where all the information is. Okay, so here we're going to restrict the geographical boundaries of the processing. So for L2Gen, you'll be able to only process what's in the location bounding box here. So you have your northwestern and southeastern boundaries in those locations, and that will make your processing faster. That actually restricts the processing, so that's important. And then we're writing our parameters here. So the input file, that's the variable we already have. The output file, this is just an automated line that will replace the L1B in your in your name with L2, so you don't really need to touch that. Then L2 prod is an important one. That's where you get your product choice. So you can, here I have just chlorophyll A, but you can have obviously multiple products there. There's the processing uncertainty. Here I turned it off because it makes the processing quicker for this example here, and I'm not using uncertainty here. And then our boundaries there are yeah, limited, and that's also something you wouldn't need to touch if you're using the location. And so this function will write the par file for us. And then we have only this little line, L2Gen par, with the par file name that we just gave it, and that will run L2Gen. If things are going well, you will see all these inputs coming up. There's a ton of them, and it may take a while depending on how large your geographical area is. So yeah, you can just scroll to the bottom as the information pops, and you will see it happen live. You will see the processing scan progressing one after the next. You can see here it took yeah, 15 seconds approximately between each step. Yeah, and then once it's done, you see processing completed at the end. If you have no error, that's where you might see error messages too if the inputs are not exactly what's expected. And yeah, don't worry. You can ask us because you can expect errors there. And then we have our level 2 file that's with the output file name that we set. So we can actually open it with Xarray now that we're in our notebook and have a look at it. So this is a limited geographical area. So I chose, this image. I'll make this smaller. Here, yeah, this is a lot of outputs. You can make it smaller with clicking on the side. That's what I'm doing here. Okay, where are we? Okay, so I started with this image, which is my homeland of Quebec with the Gulf of St. Lawrence. And where we have limited the processing to the area here, which has like a part of Nova Scotia and the Îles de la Madeleine. So yeah, so you can see what products you have now, and it's chlorophyll. So this is what we made here. So this is to customize your products, because again, we have chlorophyll on the cloud already, but you might want a different resolution or other options that Anna will tell you about. Now, those functions are a little bit more simple, and it's a little bit of the same principle. So we have L2bin that does spatial composites. Again, if you want to look at the help, the different options, you can scroll through it. Then we're going to search for 2 data sets that we want to merge together. So yeah, just location. This is a regular Earth data search. And then we're going to look at, get the S3 paths. So this is the cloud processing paths for both files. So because we have to put them after in a file that's called, well, that's the input file for L2bin that contains just the paths for our 2 files. So even if you're running it on your own laptop, it would be the paths for your files, but here they're in the cloud, so they're kind of special paths. And we're putting them in their input file and then making our parameter file with, it's the same principle, input file name, the output file variable, and then the type of product regional, that's what I use normally. Resolution you can choose here. Row group is, you might want to leave that number there. It helps with the processing time. So this is our par file, and then we run it with L2bin par with the name of our par file. And again, you will see it run live in your cell. Now I'm pre-run already, so you don't see it, but yeah. And once we have the output for this, we'll have a level 3 bin. So you might have seen in the cloud you can download L3B or L3M. Well, L3 bin is those pixels of equal size. It's the more raw version of the level 3, and the maps that have an actual projection are level 3 mapped. So to produce that, we use L3 map gen. Again, you can get the help. You can see the different projection options, for example, and different resolutions. And then we're going to, again, write our par file that has those options in there. Projection, resolution, the type of interpolation, if you're upscaling your image a little bit. There's quality flags that you can use for this. So you have those options here. And then yeah, we can run it with L3 map gen par in our par file name. And then we have our output file that we can look at it with Xarray. With data set, we can see this is the variables that we have and its coordinates. So yes, it's a level 3 mapped as we expect, and we can just plot it with matplotlib and cartopy as anything else that we've been working with so far. And now we see our 2 files that were adjacent, our 2 granules are together and combined. So this is, like I said, the overview of different functions that you can work with OCSSW. And now Anna is going to go into more detail with L2 Gen. But first, do you have any questions before we, yeah, please, Eli. Yeah.
I have a question about the L3 Gen.
Yeah.
But there was an option there where you said the resolution.
Yeah.
What are the resolutions you can?
So we can see them here. Where are they? So you have those choices of resolutions. So so you can see. Yeah, I thought this would be clearer for some reason, but.
I guess you can choose 90 to 1 kilometer for level 3 map.
And you can have half kilometer, quarter kilometer, but I'm not sure what those pixels mean here right now. Yeah, this is a yeah. Hmm? It's okay, but is it specified to the file that we're working with? Because this is in the help. That's. Okay, but no matter your input file size?
If it's global,
Okay.
if you made it global.
Oh, because it's global. Okay, okay, but you can do it with just a granule, so that will be different. Okay, 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 but yeah.
I think it's also important to point out that the resolution that you binned it to was 9 kilometers. So if you try to map from a 9-kilometer bin file to something lower resolution or higher resolution, it'll do it, but it's making up the error.
Oh, right, yeah, yeah, you might want, yeah, you want to take into account the resolution from, yeah, the first steps that you're working with, because, yeah, it will just upscale your image, and, yeah, it won't. I want to, well, you have been introduced to Brian already, but Brian is really the expert on all of this here, so if you run into, if you have questions, so please, yeah, you can refer to him if there's things that I cannot answer, or, well, yeah. Any other questions for now?
Okay.
Thank you.
Karina.